Alright, so let's say you're given this question here, throwing a ball up in the air. The question asks you, find the max height the ball reaches from throwing the ball in the air with velocity 20 meters per second. To start, we need to know the conservation of total mechanical energy. Suppose an object's weight is the only force acting on an object. So we have our mass here, and the only force acting on it is weight, equal to mass times gravity. The object is in free fall and can either be moving up or down with a velocity v. Let's consider the situation here. We consider a mass at y1 is the initial position, y2 is the final position, v1 is the initial velocity, and v2 is the final velocity. By work energy theorem, the total work is going to be equal to the change in kinetic energy, which is equal to k2 minus k1, also equal to 1/2 mv2 squared minus 1/2 mv1 squared. If gravity is the only force, work total is also equal to the work done by gravity. Gravity is the only force doing work. We know from last time that work gravity is equal to the negative change in gravitational potential energy, where delta U is equal to mgy1 minus mgy2. If we set the work total equal to work times gravity, we plug in work total is equal to the change in kinetic energy and work gravity is equal to the negative change in gravitational potential energy. We get this expression here, and then we can convert it into this form and separate the terms into the two positions, position 1 and position 2, by multiplying the negative into the bracket and bringing u1 to the left side and k2 to the right side. This right here is the conservation of mechanical energy, where k1 plus u1 is the E1, which is the energy at the start, and k2 plus u2 is the energy at some later point after. If only gravity acts on the object, the conservation of energy holds. E1 is equal to E2. So we can apply this to our example. We have the mass starting at an initial height, y1 equals 0, and we need to find the final height, y2 equals unknown. If we apply our equation here, E1 equal to E2, and convert it into this form here, we can identify that we need y2. We have the mass equal to 1 kilograms, gravity. We have the initial height equal to 0 meters. V1 is equal to 20 meters per second. V2 is unknown, but if we look at our diagram here, at the top of the motion, V2 is going to be equal to 0 meters per second, because at max height, the ball is going to stop traveling in the up direction. So we can plug all these in, cancel out the zero terms, which leaves us with this, and then we can compute the amplitudes in the units of both terms, the left term and the right term. From here, we can isolate for y2 by multiplying both sides by 1 over 9.8 newtons. Then we can do a simple division of the amplitudes into units, and we get this for the final answers. This is the max height the ball will reach. We have our ball here at a initial height, y equals 0, and the only forces acting on is the weight force, mass times gravity. And from this initial velocity of 20 meters per second, the ball is going to reach a height of 20.4 meters. And I just want to, after the ball reaches the maximum height, the ball is going to start descending.